Now we're going to look at introduction to above ground drainage systems. At the end of this part of the session, I want you all to be able to state the legislation and standards used to ensure drainage systems are installed correctly and with a high level of workmanship. State the common pipe sizes and pipe materials used in drainage, and recognise various specialist drainage fittings. Well, the purpose of drainage systems is to help ensure sanitary conditions, make sure that we improve hygiene and reduce the risk of disease. As we've discussed in the rainwater section, there's combined, partially separate and separate underground drainage systems, and these are designed to remove both wastewater and soiled water. They might have either a combined drainage where they both go into one main pipework, or there is completely separate systems in which we'd have rainwater going into different pipework, which would go without treatment to a water course, with the wastewater being taken away to retreat it. And yeah, partially separate is sort of halfway between the two, like we talked about previously. So the legislation and standards. The legislation, main piece of legislation, are Building Regulations Part H, covers drainage and waste disposal. Part G is also relevant, covers water efficiency and hygiene. Lots of excellent guidance for installing and designing rainwater and drainage systems in BSEN 12056, and this document is split into 5 parts. It's also worth being aware of BS 8000. BS 8000 is the code of practice for workmanship. Part 13 is specific to drainage systems, and BS 6465, and this gives the space recommendations, activity space recommendations around sanitary appliances. I've got a couple of examples shown here. You can see the BD on the left here, WC on the right, and both of them you need at least 600 ml space in front of it, basically somewhere to put your legs when you're using the appliance. Okay. There are different activity spaces for different other appliances, but these are the 2 key ones that we need to be aware of. So before you start work on any drainage system, if you're working in an occupied house, make sure anyone who might be affected by the work is aware. Before you start, the last thing you want is somebody flushing something down whilst you're working on the system. Okay, recommended to leave warning notices on any appliances that might be affected, and yeah, if you're working in an occupied property with only one toilet, make sure you refit that toilet before you leave the job if you do have to, or make it accessible, make it available to use before you leave the job in the evening, so the customer isn't left without a toilet, which is pretty essential, you know. Okay, so what are the hazards? Mainly, the main hazards for drainage system is the risk of infection. Again, there's a risk of Weil's disease, which is actually comes from the sort of urine of different animals, maybe foxes. I think it potentially could be from cows and stuff as well. And it's a parasite essentially, which can get into your bloodstream, and it causes flu-like symptoms, which could eventually lead to death. So make sure that you sort of stop anything like that coming into contact with your hands. Yeah, by wearing waterproof gloves. There's also a risk of hepatitis and dermatitis from the contents of the pipe. So, like I say, make sure you wear appropriate protection. Pipe materials. Like the gutters, actually, the traditional material for drainage pipes is cast iron. So in Victorian era houses, they'll have cast iron pipes, and they might use clay for the underground drainage pipes, but most of the time we're going to use plastic now, There's three types of plastic we might use. Polypropylene, normally used for waste pipes, UPVC, which can be used for soil and waste, and ABS, which again is normally used for waste. Worth noting, the ABS is the one that's most susceptible to UV degradation, damage from UV light, and you can joint ABS and PVC with solvent cement, like using these fittings up here, but you can't joint polypropylene with that. You can only joint polypropylene with push fit fittings or potentially compression fittings. You can use compression fittings on all of the types of plastic. Worth noting, okay, when it comes to plastic, as well as light that can cause it to degrade, oil can also cause plastic components to break down. Okay, so never use any oil-based putty, for example, or any oil-based products on plastic appliances or pipework. Okay, normally make your seals with a rubber washer or solvent cement in the case of your pipework sometimes. But you can also sort of use silicone sealant to seal round plastic appliances, like round our baths, or if you ever fix a grating into a plastic basin, for example. So what are the fittings? The main sort of fittings we need to be aware of are here. Actually, you can see there's a vent terminal at the top, a sort of cage at the top to stop birds nesting in there. A storm collar, also known as a weathering collar, to sort of protect from water penetration into the house. And then you've got your bends, offset bends, branch pipes. You can have a single branch, which would just have one sort of connection coming off it, or like you can see a double branch here. Fire collars here, fire protection collar, also known as an intermittent collar, to stop the spread of fire between rooms. You can also have pan connectors. This particular one's a straight pan connector, WC connector, which we use to connect the toilet into that pipe there. And air admittance valves, you can get 110mm air admittance valves, big air admittance valves, but we can also get little air admittance valves as well. And they allow air into the system, but they don't allow air out. And it helps prevent something called siphonage, which we're going to talk about a bit later on. It's also worth being aware of, you can have a boss connection. This looks like it's a multi-angle boss. You've got lots of different potential connections on there. And you can also fit a strap-on boss. And we're going to look at these very briefly as well as we go through it. Okay, so the most commonly used sizes of soil waste pipe are 110mm, 40mm and 32mm. You also might come across 50mm, 82mm as well, but these three are the most commonly installed ones. And worth noting, never ever reduce the size of a soil or waste pipe, because it's just going to lead to something called siphonage. So the size of the pipe should always be at least the same size as the largest connection. So you can see here we've got 110mm pipe coming into the main stack, so therefore all of the main stack is going to be at least 110mm. Okay. Alrighty, so connecting to the stack, when building the stack, you normally make a connection using a boss connector, and this one here is looks like it's a multi-angle boss. You can also, if you're connecting to an existing pipe, use a strap-on boss, and you can see this little finned adapter here, and that can be pushed into either of these boss fittings to adapt that size down to either the 32mm or 40mm, depending on what size you want to go into. Video here showing how to fit the strap-on boss. Essentially, you get a hole saw, you drill into the pipe at the appropriate size, file off the excess, and then put in some solvent cement onto the pipe, onto the fitting, make sure it's the right way up, strap it on, wipe off the excess. Job's again. When it comes to preventing the spread of fire, we'd use an intermittent collar. Most people would call it a fire collar. Like I say, in the test it might come up as an intermittent collar. Okay, and that should be used wherever it passes through a firewall, or normally when it goes up through the roof as well. Okay, and worth noting, if you do drill a hole, particularly a big hole for your drainage pipework, make sure you try and minimise dust, particularly in existing properties. Okay. The pipes will block up over time. It's almost a certainty, you know. So what we do need to do is make sure that we consider that and allow access for that. So you can see here on the right an access pipe, and above it an access bend. It's got a wee handhold on it. You can take that off, put in drain rods or an auger or whatever to sort of try and remove any blockages in the future. And just also need to be aware of how we prevent smells getting out. We can get temporary and permanent caps. This one here is a more sort of temporary cap. That's a drain plug that you might use, for example, if you're testing the pipework, or if you're maybe working on the pipework, you might use a drain plug there, or you might sort of cap off the pipework if you'd sort of taken permanently decommissioned something, for example. And yeah, this is the stack again. I've sort of described most of it already, and you can see all of these components that we've talked about: your access pipe here, strap-on boss, a multi-angle boss, etc., all on this stack here. Okay, so now it is time for your task.